will continue. Example number 9. Erase this. Erase this. Okay. So example 9. Okay, so this one goes like this. Given an equation of a circle, find derivative and slope at these points. So 3, 4, 0, 5, and 5, 0. Okay, so the equation of a circle looks like this. It's just going to be the upper half of it. So y equals square root of 25 minus x squared. Okay, so this is an upper half of a circle. Okay. All right, so yeah, the first thing we'll do is we'll find the derivative. So y prime just going to rewrite it, right? So I'll take that 25 minus x squared. Right, so there was a square root, so this is going to be 1 over 2, and then yeah, we're taking derivative. Okay, so yeah, the first step will be to do the derivative of the outside. So that's that half. Right, so the half goes to the front. Then I rewrite the inside function. Then so we have half minus 1, so it's going to be negative half. And then times derivative of the inside, right? So derivative, so the inside function is this, right? Negative x squared. So times minus 2x. Okay, so yeah, those 2's can cancel out. So this one and this one. Not this one. This one and that one. Okay, so this is not cancelled. Okay, so the simplified version of the answer will be something like this. So I'll have negative x, right, on the top, and the bottom is the radical. So 25 minus x squared. Okay, so that's the derivative. Or we could, right, so this is an equation for slope, right? So that basically is a formula for slope, right? So then we have those couple points that we need to find slope at, right? So we have these 3 points. So let's try to figure that out. So let's do, the first point was 3, 4. So let's do that. So at 3, right? So the slope You know, maybe before we start doing that, calculating those slopes, let's try to figure out what's going on. Okay, so let's say this is then this is 5. I know it doesn't look like 5, but it is. And this is 5. And here's the circle. Okay, let's say this is half a circle. So now, right, so those 3 points, let's look at those 3 points. So or let's look at the first one. Okay, this one, 3, 4. So what is 3, 4? So 3, 4 will be somewhere here. Okay, so 3, 4. All right, so we're looking for a slope of a tangent line, or a line tangent to that circle at 3, 4. Okay, so something like this. All right, so that's what we're trying to figure out. So that needs to be a negative number, right? You guys see that negative slope. All right, so let's see what we actually get. All right, so I'm basically plugging that x, right, that 3, into the formula for slope. Right, so let's write f prime. Right, so I'm evaluating the formula or the first derivative for 3. Okay, so let me write it here. So we have negative 3 on the top, and here we have 25 minus 3 squared. Okay, so negative 3, and here we have 25 minus 9, so that's 16, square root of 16, 4. Okay, so that slope is negative 3/4. Okay, so that's the first one. Negative 3/4. Right, so the second one we need to find this, we need to evaluate it at 0, 5. Okay, so that will be this line, and 0, 5 is right there. So yeah, the slope should be 0, right? So let's see. So at 0, 5. Okay, so again, right, I'm calculating f prime of 0, right? I'm just plugging in that 0 into that formula for slope. So 0, negative 0, right? It's just 0. And then here, it doesn't really matter what we have here. Minus 0. So we get 0 over 5, right? So that's 0. Okay? So it looks like it worked out. Right, so that's this. So slope of this line is 0. Okay, and then the last one was, and we had the point was right there, 5, 0, and this is the tangent line. Right, so I suspect the slope of this one will be undefined. Okay, so last one is at one more time. Right, so at 0, 5, 5, 0. Okay, so what we get is negative 5 on the top. Let's not do it like this. Okay, so we have f prime of 5. Okay, so we have 5 on the top, And here at the bottom I have 25 minus 5 squared. And so we get 5 over 0, and it is undefined. Okay, so that's the slope. Okay, let's just write undefined. Yeah, so you see what's happening, right? So we have half a circle, we calculated the derivative, and we found that formula for slope different for different tangent lines at different points, different locations. So first one was 3, 4, right? We calculated slope of this line, and it was negative 3/4, right? We did it by plugging in that 3 into our formula for slope. Then the next point was this point, 0, 5, and this is the tangent line. Calculated the slope, and we got 0. Okay, so it's this one. And then the last one was a vertical line, right? We know vertical line has a undefined slope. The point was 5, 0, and we calculated it here, and we did get undefined. Okay, I have a couple more examples, of course. All right, so let's do the next one. So the next one is a little bit of trigonometry. So example 10, and it goes like this. Find the points on the interval from 0 to 2 pi at which the graph of, let me write it here, right? So f of x equals 2 cosine x plus sine 2x has horizontal tangents. Horizontal tangents. Okay, so yeah, what is happening is that, right? So we know that if we take the first derivative, we're going to get if we take the first derivative of our function, we're going to get a formula for slope, right? And that slope is going to have to be equal to 0, right? Because I need horizontal tangents, right? And horizontal lines, horizontal tangents have slope equal to 0. Okay, so first step is to find the first derivative. Okay, so we have function, so f prime of x. Let me rewrite it. So 2 cosine x plus sine 2x, and then we're taking derivative of that. Okay, so derivative of cosine is negative sine, so that's going to be negative 2 sine x, and then here, and I'll have plus, and derivative of sine is cosine, so cosine 2x, and then times 2. Okay, so yeah, let me write it here. So f prime of x, so we have negative 2 sine x, and then plus 2 cosine of 2x. Okay, so at this point we have two different functions, right? And it would be nice if we had just one function, and then it's just easier to solve it, or it's possible to solve it. So what we'll do, we'll replace this part, right, with there's an identity for, right, double angle identity for cosine 2x. Let me write the whole identity, or all its versions. So cosine 2x. Okay, so that could be cosine square and then minus sine square. Okay, so that's the first version. Then it could also be 2 cosine square x minus 1. And the last option is 1 minus 2 sine square x. Okay, so if we use that last option, right, this identity, and to replace that cosine of 2x, we'll have just one function, and we'll have just sine. Okay, because this will go there, and we already have sine, so it's just gonna be one function. Let me write it here. So f prime I should edit it out, but I don't. I won't. Anyway, so we have f of x, right? So I'm replacing, now I have that 2 negative 2 sine x plus 2. Now I'm replacing that cosine of 2x with 1 minus 2 sine square x. Okay, so let me clean it up a little bit. So that's going to be negative. So negative 2 sine x plus 2 minus 4 times sine square x. Okay. Yeah, so at this point we'll make it equal to 0, so equals 0. And we can also, right, divide it by, what can we divide it by? Let's divide it by negative 2. And because at this point we're just solving it for for x's. So we can divide both sides by negative 2. Okay, so I'm going to get sine x and then we'll have minus 1 and plus 2 sine square x. Okay, that equals to 0. So finally, right, if I write that equation in a standard form, so we'll have 2 sine square x plus sine x minus 1 equals 0. Right, so we're just we could do a u substitution. Yeah, let's do that. So u equals sine x. Right, so I'm just making it into a regular quadratic equation with just a new variable u. So I'll have 2u squared plus u minus 1 equals 0. Okay, so we can factor it. I don't know, maybe I'll show you how. We can use that x. The top is a times c, so negative 2. And then we have 1. And we're looking for two numbers that will multiply to negative 2 and add to 1. So 2 and negative 1. And then, right, I put this 2 and negative 1 in parentheses like this. I also include that 2 right? That's how I do it. So 2u plus 2, and that's my first factor. In the second, I also include that 2, and then 2u, and then minus 1. Okay, so we need to tweak it a little bit, so divide this by 2, right? I'm dividing both parentheses by greatest common factor. Anyway, so I'm getting u plus 1, and then here I have 2u minus 1, and that equals to 0. Okay, so out of the first parenthesis I get u equals negative 1, and the second one gives me u equals half. Okay, so I'm replacing u with sine of x. So sine x equals negative 1, and here we have sine x equals half. Right, so I'm trying to figure out, right, for what angle am I getting negative 1, and for what angle I'm getting this half. Okay, so yeah, the answer for the first one is we need an angle between 0 and 2 pi, right? So that would be, let me show it to you actually on the unit circle. Okay, so this situation, what's going on? Okay, so maybe let's start with that half. Right, so we're looking for some angles for which sine will be half, right? And I know half is associated with 30 degrees. Right, so that's gonna be, yeah, the first one is 30 degrees, so this is my special triangle. This is 1, 2, radical 3, and this is 30 degrees. This is 60. Anyway, yeah, so sine is opposite over hypotenuse, right? So for 30 degrees, sine is equal to half, so x equals 30 degrees. And then, right, we have the second angle that also will give us that 30 degrees, right? That's this angle. Let's make a different color. Right, so that angle will be this. Right, so it's kind of good to know how to do those type of problems, right? So this will be my reference angle, 30 degrees. This is also 1. This is radical 3. And this is 2. Right, so I'll have, and that angle, the blue angle, is 150. 150 degrees. Okay, so that second solution is 150. Okay, and then from that, the other equation, sine of x equals negative 1. So negative 1, you can get negative 1 if I evaluate sine of 270. Okay, I also see that, I remember that, so this is all degrees, right? So degrees. And, right, the problem was asking about angles between 0 and 2 pi, right? So that means we should probably give the answers in radians, right? So 30 degrees is pi over 6. 150 is 5 pi over 6. Oh. Great. Five pi over 6, and here we have x equals 3 pi over 2. Yeah, so that's it. So that's the solution. Be good to see it on the graph, right? So let me sketch a graph quickly of the situation. All right, so we have and so I guess I can check it in some device, I'm not sure. So what do I have? I have 5 pi over 6, sorry, pi over 6. And then we have pi over 2. And then 5 pi over 6. 5 pi over 6. And 3 pi over 2 is here. Okay, and the graph looks something like this. Okay, so it goes up through here and then goes down. I'm not doing a good job. Okay, let me try again. So up here, and then we go down across the x-axis. Okay, here. Then it makes a little squiggly here and keeps going up. Okay, so right, we have three points where that tangent is horizontal. Right, so that's the first point. It's right there. Right, so the slope equals 0. That's the second point right there, and the tangent line. So m equals 0, and that's the last point right there. M equals 0. Okay, so that's the end of this lecture. Let me just kind of remind you at the end here, right? The chain rule, very important. Right, so f of x, let's do I don't know, 3x plus 5 to the 50th power. Okay, so we need to calculate f prime. F prime of x. Okay, so we bring that 50 to the front. That's our outside function. And then we keep the inside unchanged, plus 5. And then I subtracted 1 from that 50, so 49. And then at the end, we multiply it by the derivative of the inside. Okay, so times 3. Okay, yeah, so that's it. That's the end of 3.7.